So now that we've taken a look at what code exploits look like, let's talk about the remediation that we can do for code exploits and vulnerabilities. So first off is staying informed. This means just being up to date on what is being done out there in the world in terms of like vulnerabilities and exploits, like what's new, what's coming down the pipe, what might be getting patched soon, what might be getting updated. If you use a particular set of software, you can sign up to mailing lists and news groups related to that software, and they can keep you informed that, oh, we found a vulnerability or we found a potential security flaw with this version of this software package. And then once the update is available, you can stay up to date on when it's being released and when you can get it onto your systems. And then perhaps if it's an option, you can keep your system offline until the patch is available, depending on what the vulnerability is and how critical it is and how critical the system is too. And then that goes hand in hand with regular patching. And patching just means applying updates. So suppose you have a server and it's running Linux and somebody discovered a critical flaw security-wise or something exploitable in a particular flavor of Linux. That's when you will get informed about it. You'll find out about it, hopefully as soon as it happens. And then the next step is, once the patch is available, to apply it to all the servers that need it, and then to test to make sure that whatever you're using the servers for is still available for use after the patch happens. And so doing this kind of work is a major IT activity, and a lot of breaches, a lot of exploits happen because this work does not get done properly, because there are unpatched servers and applications out there. So it's very important for preventing exploits. Another important thing is to just avoid any kind of suspicious sources for software. Only use authorized sources to get your packages and get your binaries and executables, and not copy and paste code into your critical applications from the internet without understanding what it's doing and how it's working. Not use unsigned packages if you don't have to. Download things over HTTPS instead of HTTP, because if you download things over HTTP, there's a chance that somebody will inject malicious code into your download that way. So not getting software from suspicious sources should help with avoiding code containing exploits. Another important thing is multi-factor authentication. And we've talked about this in other places, but essentially if you have a authentication barrier in front of whatever service that you're providing to the external world, if you have multi-factor authentication, there's less chance that an attacker or some kind of automated attack bot will try to use an exploit against you, because they'll have a harder time getting in. It's not a guarantee that it'll stop it if somebody's doing the attack manually. It will still let them come in if they have valid credentials, or if there's something broken about the multi-factor authentication itself. But at the very least, it reduces the volume of potential attackers, because they'll be discouraged by having to beat the multi-factor authentication and get into your system.